Good evening, students. In my previous video I have explained about the Hund's rule, Aufbau's principle, means for how to write the electronic configuration. So let us write today electronic configuration of elements. So what is first atomic number is hydrogen. Okay, I think you might have by hearted. So hydrogen's symbol is H. So one atomic number means it has only one electron. So one electron will be in 1s1. So for writing this electronic configuration, one more scientist, Muller, has given a diagram. If you practice that diagram, you can write electronic configuration very easily. Okay, so what is that diagram? In your textbook it is given in little somewhat different. I am drawing according to mine. So now suppose first orbit is this 1s. You remember Aufbau, what Aufbau has said? Aufbau has said that always electron enters into lower energy level first. Okay, that we have to remember here for drawing the Muller's diagram. So 1s after we should not go for 1p. According to Aufbau we have to come back, that is the 2s. Then we can go for 2p. Then we have to come back again 3s, then 3p, then 3d, then again come back, then 4s, 4p, then 4d, then 4f. Okay, so now repeat the same 5s, 5p, 5d, 5f. The next now go on decreasing order 6s, 6p, 6d. The next 7s, 7p, then 8s last. Now let us draw circles for these orbits. Okay, so this diagram is given in the 10th class textbook, and almost in internet also you can get this diagram, and means for state syllabus, for CBSE, for everybody will have this diagram. So you should practice, all of you should practice. Kindly subscribe my channel and view complete videos somehow, and press the button like also. You are not liking my videos, like it. Okay, so now draw the arrow marks. See how to draw the arrow marks. First take 1s, then 2s. See, I have drawn two arrow marks with 1 orbital. Then take two orbitals, one arrow mark, then again one arrow mark. Okay, this should come in this. So here two orbitals, here two orbitals. Then take three orbitals. Okay, then again take three orbitals. See, first two orbitals, then first 1 orbital for two arrow marks, then two orbitals for two arrow marks, then three orbitals for two arrow marks, then four orbitals for two arrow marks. Now how the orbital is entering, like that you have to see. Orbital is entering into 1s first, then 2s, then 2p 3s. Okay, 2p 3s, then 3p 4s, 3p 4s, then 3d 4p 5s, 3d 4p 5s, then 4d 5p 6s, 4d 5p 6s, then 4f 5d, 4f 5d 6p 7s, then 5f 6d 7p 8s. Okay, so now as per this we have to write the configuration. So again you have to remember what s orbital contains 2 electrons, p orbital contains 6, d orbital contains 10, and f orbital contains 14 electrons. This you have to remember. Aufbau principle you have to remember. What is Aufbau principle? The electrons enters into lower energy level. Lower energy level. And what is Hund's rule? Pairing of electrons starts only the single electrons are occupied first. 1, 2, 3. Then pairing should be started according to Hund. These two principles we should remember compulsory while writing the electronic configuration. So now 1 is 1 because 1. So this is the first orbit. This is the shape of the orbit. This is the electron. Okay. So now here atomic number 2. What is atomic number 2? Helium. Symbol is He. Okay. So here 2 electrons. So s orbital can contain 2 electrons. So we can write 1s2. Then third one is lithium. Right. Lithium symbol is Li. So now we cannot write 1s3m. Why? Because s contains only 2. So second electron will go for, after 1s we have 2s, not the 2p. So write 2s, that is 2s1. The next fourth one is beryllium. Now again you have to see in s orbital 2 electrons can come. So in beryllium 1s2, 2s2 it is. Now second orbit is completely filled. Then where it goes for boron? Boron atomic number is 5. That means 5 electrons. So after 2s we have 2p. So now 1s2, 2s2, then 2p starts, 2p1. Now p contains 6 electrons. till it get complete 6, we can go on writing P2, P3 like that. So sixth one is carbon, C, 1s2, 2s2, 2p2, and seventh one is nitrogen. What is the symbol? N. Configuration will become 1s2, 2s2, 2p3. The next eighth is oxygen. Oxygen symbol is O, 1s2, 2s2, 2p4. The next ninth, fluorine. So now fluorine symbol is F, 1s2, 2s2, 2p5. The next 10th one is neon. So neon symbol is Ne, 1s2, 2s2, 2p6. Now here S2p6, we got S2p6, that is completely filled. So this is the stable element. Okay, stable element. Like that for S, this helium is also stable. Helium is also stable and neon is stable. So the remaining elements will try to become like helium, like neon, means like stable elements. Okay, what are the stable elements? Zero group elements are called stable elements. Zero group elements are what? The 18th group element in the periodic table. What are those? Helium, neon, argon, krypton, xenon, radon, and last one is oganesson. So these are the zero group, these are the stable, these are called noble gases. Okay, so remaining other elements of the complete periodic table, either by losing electron or by gaining electron, will try to get the stability like zero group elements. Okay, now let us go for 11th atomic number, that is the sodium. Sodium symbol is Na, 1s2, 2s2, 2p6 completed now. So next electron will go for 2p after 3s, 2p after 3s. So 3s1 starts. Right. 12th, magnesium. Right. Magnesium symbol is Mg. So what we'll get? 1s2, 2s2, 2p6, 3s2. Now 3s completed. So 3s after again 3p. 3p then 4s. Okay. So now 13th, that is aluminium. What is the symbol of aluminium? Al. So configuration is 1s2, 2s2, 2p6, 3s2, then 3p1. Again we can go up to p6. Right. 14th, that is silicon. Aluminum after silicon. Si, 1s2, 2s2, 2p6, 3s2, 3p2. The next 15th is phosphorus. Right. Phosphorus symbol is P. So configuration is 1s2, 2s2, 2p6, 3s2, 3p3. The next is 16th, sulfur. Okay. S, 1s2, 2s2, 2p6, 3s2, 3p4. The next is 17th, chlorine. Right. Chlorine symbol is Cl. Then 1s2, 2s2, 2p6, 3s2, 3p5. Then 18th, argon. Argon is nothing but stable. See here, argon. Okay. 1s2, 2s2, 2p6, 3s2, 3p6. Again see, S and P are completely filled. So this is also a stable element. Okay. Then going for 19, that is potassium. K, 1s2, 2s2, 2p6, 3s2, 3p6. Now next orbital is, see here, 3p6 after 3s after now 3p now 3p after 4s. So here it starts 4s1. The next is 20, calcium. So in calcium, symbol is Ca. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay. So today we learn up to calcium. Then next class we will go for D block elements, that is 21 to 30, because there are some exceptional cases in chromium and copper. So I will teach in next video. Now you see here, I will show you how to write the valency of these elements. Now when you are going for valency, see first and last outermost orbit. Outermost orbit means last orbit. See here is the first orbit only, but in this case second orbit is the last. Then again third orbit started. So third orbit is the last. Here fourth orbit is started. So fourth orbit is the last. If you draw the diagram, so who has drawn this diagram? Bohr. So that is called Bohr's atomic model. Okay. Let us draw, for example, we can take lithium. Okay. Lithium atomic number is 3. Configuration is 1s2, 2s1. So first to draw the nucleus, and inside the nucleus protons are 3. Because atomic number 3 means protons also 3. Then neutrons are how many? Neutrons are 4 because its atomic mass is 7. Lithium 7, 3. Okay, so 7 minus 3 is 4. Right. Now electrons are how many? 2 plus 1, 3. So in first orbit, that is 1s2. So draw 2 electrons. And in the second orbit only 1 electron. Okay, in the second orbit only 1 electron. See here. So this is called outermost electron or outermost shell. That is also known as valency shell. Okay, valency electron. It is present in valency shell, or we can say outermost electron, outermost shell. Now here you see, in the second orbit there is 1 electron. So if it loses this electron, if we remove this electron, it will become like helium. Na? Helium atomic number is 2. Configuration is 1s2. See nucleus. In the nucleus we have 2 protons and 2 neutrons. So in first orbit, that is there are only 2 electrons. So this is the stable now. So lithium, by losing 1 electron, it can become like helium. Okay, that means its valency will become 1. Its valency will become 1. So like that you can go for any other atom. You can take, for example, chlorine is there. Atomic number is 17. So configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, see here 2 plus 6, 8, 2 plus 5, 7. Total 17 electrons, right? So the last orbit is third. In third orbit there are how many electrons? 7 electrons, right? So let us draw chlorine. Chlorine, the protons are 17 because atomic number is 17. Then neutrons, that atomic weight is 35.5. They are taking the average because chlorine is showing 2 atomic weights. So let us go for the number of electrons. So in first orbit how many electrons are there? Only 2. Always in first orbital only 2 electrons. The next second orbital we have how many electrons? 2 plus 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then go for third orbit. 2 plus 5, 7 electrons. So in the third orbit we are drawing 7. 1, 2, 3, 4, 5, 6, 7. So 1 electron is needed because p orbital contains 6 electrons. So how many are required? 1 electron. So we can see like this. S orbit 2 electrons, p orbit contains 6 electrons. So we have 2 plus 6 is 8. Okay, that is called octet rule. What it is called? Octet rule. Now I will explain you what is octet rule. So here now totally 2 plus 6 should be 8, but here only 1 is needed. If we add 1 electron in this chlorine, it will become like argon, no? Because after chlorine we have argon. You see, argon's atomic number is 18. Argon's atomic number is 18. If you draw argon, that means configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, that means C2 plus 6 is 8. 2 plus 6 is 8. So in argon 2 plus 6 is 8, whereas in chlorine 2 plus 5 is 7. So we have to compare with the 8. So 8 minus 7 is 1, right? So it needs 1 electron. It needs 1 electron. If 1 electron is added here, it can become like argon. That means its valency is again 1, right? So let us see one by one all the elements. Now here you see hydrogen is having 1 electron. If it takes 1 electron, it can become like helium. So its valency is 1. And this valency is 0 because S contains 2. 2 minus 2 is nothing but 0, right? Now here the outermost orbit is second. So again 1 electron. By leaving 1 electron, by losing 1 electron, it can become like helium. So valency 1. By losing 2 electrons, it can become like helium. So valency 2. See, 2 plus 1 is 3 here because P is in the last. We have to consider S plus P. Okay, S plus P means here how much? 2 plus 1 is equal to 3 it is becoming. Now 2 plus 1 is 3. If we compare with 8, 8 minus 3 is 5. So just you think about this. Nobody can give 5 electrons to become like neon. Okay, it can become like helium by leaving this by losing these 3 electrons. By accepting 5 electrons, it can become like neon, and by losing 3 electrons, it can become helium. So which is easy? Losing 3 electrons is easy, or gaining 5 electrons is easy? Losing 3 electrons is easy. So its valency is 3. Now 2 plus 2 is 4. Now here you see 4 means, now 8 minus 4 is 4. So losing 4 electrons also same, gaining 4 electrons also same. So its valency is anyhow 4. Now 2 plus 3 is 5. 2 plus 3 is 5 means you would see here 8 minus 5 is equal to 3. Losing 5 electrons is easy or gaining 3 electrons is easy. So gaining 3 electrons is easy. So its valency will become 3. So now 2 plus 4 is 6. So 8 minus 6 is 2. Now 2 plus 5 is 7. That is 8 minus 7 is 1. See, it is increasing and decreasing, you see. 0, 1, 2, 3, 4. Then 3, 2, 1. Then again for neon it will become 0. Valency will become 0 because 8 minus 8 is 0. Then coming for sodium, the third orbital is S now. S means it should contain 2 electrons. But here it is having 1 electron. So one more, instead of taking 1 electron, if it takes 1 electron, it can become like magnesium, but cannot become like argon. So it can, by losing this 1 electron, it can become like neon. So its valency will become 1. And magnesium, by losing 2 electrons, it can become like neon. So valency 2. And here in case of aluminium, again p orbital is started. So you have to add 2 plus 1 is 3. So 8 minus 3 is again same like boron. Okay, 2 plus 1 is 3 now. So losing 3 electrons is easy comparing to gaining 5 electrons. So valency will become 3. Now 2 plus 2 is 4, same like carbon. So 4 giving or taking same, so it will share. So its valency will become 4. Now 2 plus 3 is 5. Okay, losing 5 electron is not easy. So it can gain the 3 electrons. So its valency is 3. 2 plus 4 is 6. So 8 minus 6 is 2. So instead of losing 6 electrons, it can get 2 electrons and become like argon. And it will gain 1 electron, become like argon. So now again for argon its valency is 0. Now again coming for fourth orbit. So by losing 1 electron it can become like argon. So valency is 1. Now here by losing 2 electrons it can become like argon. So its valency is 2. Okay children, thank you. In my next video I will go from scandium to zinc. Okay.